Oh, hey. Oh, didn't see you there. Well, you're kind of in for a treat. This just arrived. This is my FLSun Q5 3D printer. This printer is also known as a Kessel printer. That's Kossel with an O, K-O-S-S-E-L. You're not going to be making any runs with this thing. It's a Delta printer. You can join me as I unbox this, set it up, put it together. I'll go over the various quirks and features, and maybe, who knows, when I'm done, I'll give it a Doug score. If you're not familiar with Delta printers, they're kind of unusual. It uses 3 motors to move the effector around, the effector being the print head. It's often described as kind of a mesmerizing look, or a robotic look, or even insect-like. But of course, everybody knows that it's actually aliens. So, in the spirit of alien autopsies, let's dig into this thing and see what makes it tick. A trusty Gerber tool here. Let's cut into it and find out what's going on. Box is actually a little on the small side, not very tall. And from what I've read about this, it's pretty much mostly assembled already. It's kind of like it was assembled at the factory and then they took it back apart and put it in the box. So it shouldn't be that difficult to do. Okay, so here's going to be the 3 arms. These are the engines. They're going to move the effector. Called a Delta printer, by the way, because alpha, beta, delta, 1, 2, 3. Typical power cord. User manual. Doesn't have a whole lot in it. Assembly instructions are pretty easy. Precautions when using automatic leveling. Certificate of approval, pass inspection. That's always a bonus. Looks like a USB cable. Here's going to be your standard stuff. Here's a putty knife. Interestingly, some of the other reviews I've read about this talked about the blade not being edged, but I don't know if you can see that or not, but it clearly has an edge blade on it. Interesting. That is going to be the assembly that holds the filament spool to the top of it, I'm sure. This is probably going to be the control rods that connect the arms to the effector, would be my guess. Shrink wrapped, or saran wrapped rather, a little frustratingly. Yep, that's clearly what those are. That's already all pre-mounted and everything, so that was handy. Oh, come on guys, get this out of here. Eight days later. Okay. I can see those. Pull this. Okay, so that is going to be probably the roof of the thing. Yep. I'm not really wanting to come out of the foam. Well, let's pull this other stuff out first. Okay, so here's actually the effector. You see the Bowden tube going up to it. Cheap little fan. Nothing particularly surprising there. That looks like a runout sensor, a brake sensor. Oh, standard little toolkit. Got some side snips and some various wrenches and zip ties and Allen wrenches. Looks like a SD card and a reader in there. So that's kind of handy too. Now this guy comes out. Yep. This is going to be the roof of the thing. Most of the electronics on these are on the top. These printers sit rather low when they're actually assembled. The print bed itself doesn't move. We'll get into that here in just a little bit. And we'll pop this open. There's something interesting going on in the electronics in here that I'm actually already aware of that I'd like to point out. We'll get to that in just a little bit. Take this. And then as a final piece, oh, there's one more. This is the print bed, glass print bed, heated. So that's supposed to work really, really well. And some undoubtedly, questionable PLA. We may or may not try to print something to that. We'll see. So that's pretty much what's in the box. And then here in a second, let's crack this thing open, look what's inside of there, and then we'll put it together real fast. So I thought I'd spare you the tedium of watching me unscrew the lid off of this thing just to prove a point. And that is that if you notice, there's these three sort of socketed chips here, and or chip assemblies, and then there's a chip assembly here that is a little bit different. What we're looking at here are the stepper drivers. These three are for the three motors, the three legs that move the effector around. This is for the extruder. You notice it is different. And what they've done here, and it's understandable because this is a $200 printer and they're doing everything they possibly can to save as much money as possible. But these three stepper drivers here are TMC 2208s, which are known for being particularly quiet. Most motherboard upgrades that are silent motherboard upgrades, etc., are really what they're doing is just including this particular stepper driver. It uses a particular technology called a stealth chop, and what it does is it changes the way that the steppers kind of come in and come out of their movements. It makes them way considerably quieter. These you could probably pick up wholesale for $5 or $6 each. This thing probably costs $1, if that much. This is an old A4988. This is a very loud stepper driver. And it's just odd to me that for a couple bucks, they could have put the right driver here and really made the extruder considerably quieter. I suspect it's going to be probably, aside from the fans, the loudest part of the entire printer. Okay, so here we have the completed FLSun Q5 printer. I brought in my Ender 3 as well to use that as the basis of comparison. So when I'm talking about certain things this printer does, I can show you how that does in a traditional sense, how it compares traditional sense. I believe the build took 45 minutes and 15 seconds. We're going to let that idiot that could not focus his camera work on that back here while we're talking about the printer itself. The build had no big surprises in it. It's extremely simple. I spent a whole bunch of time goofing off. Making sure that this effector was pointing the right direction was probably the most difficult thing about it all. It has the picture's really nice. It's really well worded. It uses the same set of screws to put everything together. That's really nice. You don't have to worry about that. You don't have to try to keep track of that kind of stuff, anything like that. And I probably, if you were going to rush a build, you could probably do it in 20, 25 minutes easily. It was pretty straightforward. So I thought I'd go over the why of this printer. Why does it even exist? How does it compare to other printers that are in its kind of same price range, and really kind of what its target is? Now, this is a Delta printer, and how that really differs from a traditional printer is the way that the print head moves. It's called an effector in this. In a traditional kind of Cartesian printer, we're used to things going back and forth. This goes back and forth. You kind of think of this in a 3D system. Everything is left, right, up, down, back and forth. In this, there's three separate arms that move the little head around, And as you can see, the movement of the arms actually determines where the head is going to be. Now, this is not in any way Cartesian. It's in the way that we would think of things. It's difficult to kind of process this as to exactly where you would move this to make this go. It is not in any way something that we would normally see as being intuitive in any way. And clearly, the model behind this, the way that the math is put together and everything, comes from aliens. No one pays attention to me. It's obviously aliens. In any event, one of the neat things about the Delta printers, and the actual reason that they exist, is that when you're moving just this piece, just the effector, there's very little mass. So as things are moving around, you don't have to worry so much about, like, for example, on an Ender and most traditional printers, at some point this table is going to move. Now, in some cases, the table's handling I guess this would be the Y motion. In some cases, it's the Z motion, like in an Ender 5, where the table moves down. But in any event, this table at some point is moving, and when that table moves, there's an immense amount of inertia there, as well as just the inertia of this head moving back and forth. What that ends up as is it slows things down and makes things, in some degree, a little less precise, because there's mass you have to stop moving. This has almost no mass. And at any given moment, it has 3 separate engines that are controlling the precision of it. This should be considerably faster, should be considerably more precise. And on top of that, it just kind of looks cool when it's running. They both cost around $200. There's been a lot of things done to this printer to kind of make it a little less expensive. Like I had pointed out the focus problem where the stepper motor, or stepper drivers, saved a couple bucks here and there. The one thing that you're going to see is different is, even though these printers look physically about the same size, and these print tables look about the same size, the print beds, this actually only has about half of the volume, the print volume, that for example, an Ender 3 would have. This theoretically has a 200 by 200 by 200 cone of printing space. And the reason it's a cone is because when you get up to the top here, for example, even though the printer's up here, to move over to this side, this arm has to move down. In this case, this arm moves down, and as that happens, the print head goes low. So you've kind of got this really effective use that's sort of a truncated cone as it gets up to the top. That's generally not going to be a big problem unless you're printing a giant cylinder. But it does mean that it has less volume as opposed to the 220, or some would argue 235 by 220 by 250 millimeter range that this has. So your Cartesian system is generally going to have a little bit more flexibility as far as the print volume is concerned. This does use slightly less space, both in the size of the footprint of the thing itself, and also you don't have to worry about this piece moving back and forth. It doesn't have anything like that. The effector does all that movement. The Ender 3 is much more open source than this is. So there's a huge ecosystem of additions and changes and modifications. This particular printer has many of those done to it. I have an auto leveling system built into it, and I have I've added to it rather, and I have a different motherboard changed to silent printing and everything like that. You're not going to see that stuff for this. You might find some things where you can print some little hacks for it and everything, but you're not going to see motherboard swaps really for this kind of printer. You're certainly not going to see software changes on it. This does not use Marlin. It uses a proprietary system that would seem to be just as good. It doesn't really have any issues with that. But if you're the kind of person that likes to kind of tinker and hack and go on there and change little things like that, recompile a version of Marlin for yourself, this one is not going to work that way. I think there's a couple people out there that have managed to get Marlin 2 to work on this, but it's not trivial. And you spend all your time just doing that instead of actually printing, which is the more thing you want to do. Between the two of them, this one does look much cooler when it comes to printing things. And when you just sit and watch stuff, even though this has its own sort of hypnotic kind of quality to it, nothing beats a Delta printer when it's printing. But so, given the restrictions that the Delta printer has, volume, most notably, in this particular case, lack of hackability, why would you ever consider this printer? And the big thing, the big thing is speed. There's just no mass in this thing to move around. Even if they're both theoretically printing at the same speed, say 60 millimeters a second, it takes more to get this print head moving and stopping than it does to get this one moving and stopping. And at those higher speeds, this is going to be considerably more precise than over here. And the top speeds of this should be much higher. As a matter of fact, even on the box, if you look in the box of the thing, it says something about printing things faster, printing at speed. And like I said, and the precision is going to be better. And it even precision on certain things like, you know, the Z, how high it comes off of this. Z being, you know, zeta for zeta reticuli, because this thing floats a lot like a flying saucer. It's just an alien thing. People just don't believe me on that. But I don't know why. But now let's, so that's the basics of it. Kind of some fundamentals as far as theory and things. Let's go ahead and print something. So the first thing to do is the auto leveling. Turn the power on here. You should see the display come up. There we go. It's a nice little color display. I'm pretty sure you can see that. So this piece that I had initially misunderstood as the brake sensor, which it doesn't have, is actually a leveling device. It's got a little magnetic clip on it and sort of a pressure sensitive switch down here, and the thing just kind of snaps in to the print head like that. This cable comes up, plugs into this little spot, which I'm not sure you can see it or not. I got my hands in front of it. And then we go ahead and go and do the auto leveling. So let's go ahead and try that. So what we're going to do is we're going to click on Tool, and then we're going to click on Auto Level, and then Auto Level once again. Please plug in the leveling switch module before auto level. It is. I confirm that. And it's going to do its thing. My understanding is that this will take some time. I'll just set this in speed up mode, and then you can sit and watch it as it does it. After I got done with the auto leveling, there was some minor kind of stuff where you adjusting the Z value to make sure that it's in the exact right spot. You level it with a piece of paper like you're used to doing. But then after that, you save it. It remembers it from that point on, and it should really be a rare circumstance when it needs to be re-leveled, since that the print bed doesn't move. I did have an issue when I was first trying to feed the filament through. It did not want to feed. There was some kind of a blockage, some kind of material in the print nozzle. I ended up having to pull the nozzle off. I'll throw a picture of that up. Hopefully you can see it. It looks like kind of a white PLA, or almost like a white grease. When I did manage to get it forced through, what came out of it did not look like PLA at all. It was much more liquid than PLA. But that's all taken care of now. I do have to say that I am not particularly fond of the way that is mounted versus the way that the extruder is set. It just feeds filament off to the side in kind of an odd way, and I think that needs to be moved about 30 degrees, 45 degrees to get a more straight line for that print to go in. I'm not really sure why it's done that way. I'd like to point out that there's not a setting inside of Cura for this particular printer yet. So what most people have suggested to do, and seems to work really well, is to use the FLSun Q5, and then of course go into Cura and change the parameters of the printer itself to 200 by 200. And that seems to work pretty well, and that is the settings that I use to slice this particular model. All right, so I've got the model on an SD card, got the SD card into the printer, got the printer set up, told it to print. It's currently heating up. We'll put this into time-lapse mode, speed up mode, and see what comes out. And I would like to also say that I am printing this in bright green because, you know, everyone wants a bright green Klingon, right? All right, so the print is done. As it was cooling down over here, I could hear it kind of popping and cracking, which is a good sign to me. It makes me think that it's probably going to come off of here pretty easily. Let's just see how it's... oh, well, okay. Well, that came right off. That is very handy. This particular model, the reason I chose this particular model, first off, it's one that I have made, and it's up on Thingiverse. I can put the link up for you if you want. Is because often it's pretty difficult to get off a print bed and keep it kind of consistent as, or keep it as, you know, one big piece here. It's real easy to mess this thing up when you're taking it off the bed. I see a little bit of stringing here and there. I don't know if it's showing up on the camera or not. That looks like it might need to be, the extrusion settings might, or the retraction settings might need to be messed with just a little bit. Overall, the model is very clean. Another reason I like this one is because you can see there's a lot of surface area to look at. And then when you assemble the model, if the little pieces aren't, you know, dimensionally accurate, they won't snap together very well at all. So it's actually, to me, it's a very good test print. And this one looks really, really, really good. I am just, I'm really impressed with this. We'll put this thing together and throw some final thoughts together and be done. Well, everything snapped together just beautifully on my little model. I am really impressed with this. It came out looking really, really, really good. Let's see if I can get some light up here on it. You know, everyone needs a green Klingon. So overall, I am very, very, very impressed with both the speed and the precision on this. It is really cool to watch, obviously. It does run in the $200 range. I'll put a link down there for, I believe you can find this on Amazon. And I sincerely hope you enjoyed watching me mess around with this thing. I mean, just look at their logo. There's a flying saucer on the logo. Look at it.